Hello everyone, welcome to SlideScope's Power BI tutorial series, and in this video we are learning important financial functions in DAX in Power BI. So DAX provides several financial functions to calculate values like interest, depreciation or loan repayment schedules. These functions are helpful in financial modeling and analysis. So here are some important financial functions with example using a sample data set. So we will give you a sample snippet of data and explain if you will apply these functions, then what will be the output. First function is PMT function. Obviously, there are many financial functions related to DAX which are provided on DAX website. We are covering some important functions here, and if you will learn them, then basis of this knowledge you can apply it on other financial functions as well. So PMT has four three main parameters here: rate, N per NPV, and two optional. So rate is interest rate period. PMT calculates payment for a loan based on constant payment and constant interest rate. So if we have a constant interest rate and we are making constant payment, then it will calculate payment for a loan. Rate here is rate of interest. N per stands for total number of payment periods. PV represents present value, that is the loan amount. FV gives us the future value, or you have to enter the future value. Default is 0. And type is payment timing. 0 means end of the period and 1 means beginning. So at which time you are making the payment. Let's say a very basic data set here. So here loan amount, which is PV, is 100,000 or 10,000, sorry, here, and loan amount PV in loan ID2 is 5,000. Interest rate here is 5%. So this is 10,000 loan amount at 5% rate, 5,000 loan amount at 7% rate. Similarly, you can have a data set where you have thousands of rows, and for every loan ID you may have these values. And this is the period, that is 12 or 24. Total number of payment periods. Okay. Now, if you will apply DAX formula, first you have to select the loan interest rate divided by 100 divided by 12. So this way you will get the actual interest rate. Then in the second parameter you write N per, that is total number of payment periods, which is periods, which will give you a dynamic value. And then you write minus loan amount. So that is loans amount. Let's say the name of this data set is loans. So loan amount here will be your column where your loan amount will be there. And you will get an output like this. And this will give you the payment for loan based on constant payment for a constant interest rate. For every loan ID, you will get this type of output. So these financial functions will help you in calculating payment for loan. And you have to create a calculated table. So in your modeling, if you are using a dataset, you can use a calculated table to apply this formula. Hence, your monthly payment will be a calculated table. Similar to PMT, there is FV, which calculates the future value of an investment based on constant periodic payment and a constant interest rate. Suppose you are paying a constant amount of some amount constantly over a period of time, and you also have a constant interest of rate. It is not varying. and you want to calculate the future value of an investment. So for that, you will use the FV formula. In FV, again you have five arguments. First is rate, second is N per, which is same as above. Third is PMT. So if you know PMT, then you can calculate FV. Fourth is PV. Then we have type. Type will be payment timing 0, end of period 1, beginning. That means you are making the payment for, obviously you are making constant payment, but are you making those payment end of the period or beginning of the period? Sometimes we pay some amount before the month starts, and sometimes we pay after the month ends. PMT will be your payment made each period. So for example, there let's consider two people who are investing some money, or one person has invested in two different investments. So every investment has a unique ID. This person is paying 500 monthly. It can be anything, dollars, rupees, anything. At interest rate of 6, and periods, that is N per, which is total number of payment period is 12. So this person will pay 12 for 12 periods. This person will pay 500 rupees per month at 6% interest rate, and second person will pay 300 at 4% for 24 months. So future value will be, let's say the name of this data set is investments, or this table is investments. So you will write interest rate here. Make sure you are writing proper name of your column. If your column name is given as interest rate percentage, you can write interest rate percentage like that. So you are writing investment interest rate divided by 100 divided by 12. This will calculate your actual interest rate. Then your investment period, like for how many periods you are investing, and then minus investments monthly payment. And this way you will get your future value. So if you are wondering why this negative sign here or negative sign above, the negative sign in investment monthly payment is used to align with the cash flow convention commonly followed in financial calculations. For example, for outflow payment, represent money going out of your pocket, which are treated as negative values, and inflow payments or receipt represent money coming into your pocket, which is treated as positive values. Application in the formula are FV, PV and PMT. PV is something that you will learn just after this. The payment amount PMT or present value is treated as outflow, so it's negative. The future value is typically treated as inflow, so it's positive. Here we have negative value. So by using minus investment monthly payment, we are indicating that this is cash outflow. So future value will be 6 by 100 by 12. Let's say 6% interest rate for 12 period minus 500. Here minus 500 represents the monthly payment you are investing outflow. The function will calculate the total value you will receive, that is inflow, at the end of period. So that's why these representations are depending upon whether it's outflow or inflow, it is positive or negative. Why not make payments positive? If you don't use the negative sign, the financial function may interpret your payment is an inflow, that is money received, which would lead to incorrect result. There are some real world perspective. This convention helps maintain clarity in scenarios where you pay money today, negative. You receive money today, positive. To get a return later, positive, and pay it back in installments, negative. So to get a return later, positive, to pay back in installments, negative, and by keeping these signs consistent, the formulas align with real world cash flow analysis. So make sure about when you are using something in the formula, you use the signs properly. Loans, investments are all something that we give. The loan amount, the monthly payment, and what we receive is positive. Similar to PMT and FV above, they also have PV, which represents present value of any investment or loan based on periodic, constant payment and constant interest rate. So in this case, we have considered that, you know, in this case, if you are, it will calculate the present value of investment or loan based on your periodic constant payment, and it will calculate future value 12. So suppose you are investing $500 every month at 6% annual interest rate for 12 months. The formula is this, which we learned. In PV, again you have the same parameters: rate, N per, PMT, FV and type. So again consider a loan ID. 300 and 500 are the loans taken in both IDs respectively. Interest rate is 8% and 5%, and the period for which loan are taken are 36 and 12. So here again you are using the interest rate, loan periods and loan monthly payment. So it will calculate 8565 and 10685. So these are the present values. That means present value of an investment or loan based on your constant periodic payment. Similarly, we have XNPV. It calculates the net present value for a schedule of cash flows that is not necessarily periodic. Earlier, every payment was periodic, and this is net present value. So here you write rate, values, and dates. For example, transaction date, in this case, transaction date will be different. So one transaction was made in 1/1/2023. Another was made in 1/6/2023, and third payment was made on 1/12/2023. Here cash flow was, so this is not a payment made, this is basically a transaction which can be either credit or debit. So this was debit, then credit, and then credit. So the net present value will be 0.05, then your cash flow. So it will be a calculated table that will take all the cash flow and cash flow transaction date. This is rate. So we have considered that rate is 5%, and hence it will give you net present value 784.21. Similar to XNPV, we also have XIRR function. The purpose of this is to calculate the internal rate of return for a schedule of cash flows that are necessarily not periodic. So earlier we studied that XNPV will calculate the net present value for a schedule of cash flows that is not necessarily periodic, the net present value, and this will calculate the internal rate of return. Here also you have values and dates, but here you don't have the rate. So here you just write your cash flow, that is your value, and cash flow date, and then it will give you the internal rate of return. Like internally 11.5% is your rate of return. These are some summary. PMT calculates periodic payment of loan. FV calculates the future value of an investment. PV calculates present value of an investment or loan. XNPV calculates the net present value of irregular cash flows, and XIRR calculates the internal rate of return for irregular cash flows. These financial functions are powerful tools for financial modeling and can be tailored for business scenarios like loan payment, investment growth, and profitability analysis. Other than this, there are functions like ACCRINT that returns the accrued interest for security that pays periodic interest. Then ACCRINTM returns the accrued interest for a security that pays interest at maturity. So if interest for a security is paid periodically, you can use this. If interest is paid at maturity, you can use this. And here you will find like issue, first interest, settlement rate, par frequency. So here also you will, if you will try to understand, they have given the formula also, and they have given some example like 1st March 2007 is issue date, 31st August 2008 is first interest date, 1 May 2008 is settlement date, 10% is coupon rate, and so on. And then you can evaluate like this: accruing date, 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 point 1, 1000 and 2.0. So you are writing your date 1, issue date, first interest date, settlement date, coupon rate, PAR value, frequency is a semi-annual, and then 30 by 360 basis. So whatever is given here, and based on this you will get your return. It will give the accrued interest from issue to settlement. So these are some financial functions that you can try to get hold of financial analysis, and with the help of these functions you will be able to do, you know uh, we will be able to deal scenarios like loan payment, investment good, etc.